Hi friends, welcome to the unit for day one. We're going to be jumping into now verifying inverses. To verify inverses, we have to do function composition. So if we take the composition of f and f inverse composed with x, and then if we arrive back at the original x that we used, then we know that it's a one-to-one if also. So it has to work both ways. Essentially, we have to take the composition of f and f inverse, and then also f inverse with f. And then if we arrive back with x both times, then we know that it is in fact an inverse. So we're going to verify the examples that we did previously. So here we're going to verify that the inverses that we found in example 2.2 and 2.3 are in fact inverses. So this is f of x, and then our f inverse of x was x cubed plus 2. Equal to x cubed plus 2. So I'm going to compose these. So function composition, so I'm going to compose, so f composed with f inverse of x is equal to, so essentially I'm going to take this x cubed plus 2 and plug it in to that x there. So I have the cubed root of this x, so that's x cubed plus 2. And then minus 2, and then this is all underneath the same cubed root. Now when you're verifying this, essentially what's happening is you're simplifying as much as possible. So with the verification here, all you're doing is simplifying. X cubed plus 2 minus 2. The plus 2 and the minus 2 actually cancel each other out, so I have the cubed root of x cubed, and the cubed root of x cubed is x. So this does in fact verify this way. Now I need to verify the other direction. So I need to verify f inverse composed with f of x composed with f of x. That looks like the word of, it's composed with. Kind of hard to tell. This is the function composition notation. So now we're taking this and plugging it into this x here. So here I have the cubed root of x minus 2, and then that's cubed, and then plus 2. So the cubed root and the cubed, those cancel in this case. So I have the square root of x sorry, not the square root. Oh my goodness. Had a moment there. No roots. The roots are gone. I have x minus 2 plus 2. The minus 2 and plus 2 cancel. And cancel. 0 cancel. So I'm left with just x. So this does verify that they are both inverses. That f inverse of x is in fact the inverse. Now doing the same with 2.3. So first, let me copy over what f inverse of x is from the previous page. So that's x over x minus 3. So this one gets a little bit hairy because there's multiple x values when you plug them in. So let's go this way first. So I have f composed with f inverse of x. That means I'm going to take this and plug this in wherever I see an x here. So that gives me 3 times, so this x is this here, so 3 times x over x minus 3 all over this x over x minus 3 minus 1. So a lot of simplifying to do. Here, I need these to have the same denominator, so I'm going to multiply x minus 3 over x minus 3. So now, in this denominator here, actually let's simplify both. So the numerator here, 3 times x is 3x, so this will be 3x over x minus 3, all divided by. Now I have x, this x here, minus, parentheses, x minus 3, all over x minus 3. I can simplify this, distribute that negative. So I've got 3x over x minus 3 all over x, and then minus x plus 3 over x minus 3. This x minus x cancels. So now what I have is this 3. Now I can turn this into 3x over x minus 3 divided by 3 over x minus 3. So now we can multiply by the reciprocal, 3x over x minus 3 times x minus 3 over 3. Now you see that we have a lot of simplification here. These x minus 3s and x minus 3 simplify, the 3's simplify, and we are left with just x. Hooray! That's what we wanted. So that does verify that direction. So now we need to verify also that it verifies the other way. F inverse composed with f of x. So now we're taking the 3x over x minus 1 and plugging it into this x here. So if I do that, that'll give me 3x over x minus 1 all over 3x over x minus 1 minus 3. So for this to have the same denominators, I need to multiply this side by x minus 1 over x minus 1. So then that gives me 3x over x minus 1 all over 3x minus 3 times parentheses x minus 1, excuse me, x minus 1 all over x minus 1. So then distributing here, that's going to give me, so let's say I have 3x over x minus 1 all over 3x minus 3x plus 3 all over x minus 1. You should see that it looks very similar to the other one at this point now. These 0 cancel, and we have 3x over x minus 1 all over 3 over x minus 1. So we have 3x over x minus 1 divided by 3 over x minus 1 equals 3x over x minus 1 times, multiply by the reciprocal, x minus 1 over 3. And we we simplify here and here. And now we're left with just x. Done. All right. So let's verify that they're inverses. So whenever you verify that a function is an inverse, when you compose them, you should arrive back with x. So let's talk about the graphs of the function and its inverse in the next video. I'll see you there. Have a good day.